We have the second portion of exponents. Here we call it exponential equations. Exponential equations. So what we're going to do here, it's all about solving for x. We're going to solve for x. When we talk about exponential equation, it means that we are solving for x. So they're going to give you two things. One thing that you need to note, number one, they said solve for x. Solve for x. So obviously you'll be given these equal signs. So now here we're interested in two things. Number one, the basis must be the same. Basis must be the same. Must be the same. Or exponent. Or exponent. So if the bases are the same, the answer is the exponent. If the exponent are the same, then the answer is the base. So now a quick one will be, say, given that we've got x to the power of 4, it's equal to 16. Then the question says solve for x. In as much as you see this thing, it's either the bases are the same or the exponent. So now I'm going to change 16. There are two ways in which I can change 16. I can use 2 to the power of 4 or 4 to the power of 2. So now obviously here, because of that 4 and the 4, so which means that I'm going to say x to the power of 4, it's equal to 2 to the power of 4. So because the exponents are the same, then my answer is the base. So then I am done. So when I put 2 here, you can always prove this thing. When I put 2 here and I say 2 to the power of 4, I will always get 16. This is what we call exponential equation. Okay, then number 2, we're still on it. We have 2x to the power of 3, it's equal to 54. Then what we're going to do here is very simple. We have to get rid of the 2. How do we get rid of the 2? What you do on the left hand side, must be done at the right hand side. Then we have x to the power of 3, which is 54 divided by 2, that is 27. So that is 27. So now we have to change 27. How do we change 27? 27 is the same as x to the power of 3, which is equal to 3 to the power of 3. So now here what we have, as usual, the exponent are the same. So in as much as the exponent are the same, therefore the answer is the base. Then you are done. So that is basically what we'll be doing here. So let me just launch it deeper a bit. We have the third one. In the third one, I have 3, then x, negative 3 over 4, it's equal to 24. Remember, rule number 1, this one, we must have the coefficient of 1. So because of it is 3, we're going to divide by 3. What to do on the left-hand side must be done at the right-hand side. Then we're going to have x to the power of negative 3 over 4. It's equal to, then I've got 24 divided by 3. 24 divided by 3, if you have a calculator there, you will realize that it is 8. It is 8. Then from here, I can change 8. How do I change 8? That is the same as 2 to the power of 3. Then I'm going to say x to the power of negative 3 over 4. It's equal to 2 to the power of 3. Mind you, I will have to get rid of this guy here. I will have to get rid of negative 3 over 4. So if I want to get rid of that, the law says that what you do on the left-hand side must be done on the right-hand side. So I'm going to multiply by negative 4 over 3. So because I've done that, the reason for multiplying is to get rid of the fraction. Then that will be 2 to the power of 3 multiplied by negative 4 over 3. What you do on the left-hand side must be done at the right-hand side. Then this cancel, that cancel, that cancel, that cancel, and the negative will cancel. Then the remaining will be x, it's equal to. Then this side, 3 and 3 will cancel. Then the remaining will be 2 to the power of negative 4. Then such can be written as what? As x, it's equal to 1 over 16 when you use a calculator. That is what we'll be basically doing here. Very interesting to work on. Okay, then now we have another one here, which is says solve for x. You have x to the power of negative 1 over 2. It's equal to 1 over 64. Okay, then I will use a different pen here to say that it's a new one. Okay, now when you see something like this, we have to change that 64. We have to change the 64. That will be x negative 1 over 2. It's equal to, we can change it in terms of 1 over 8 squared if you want to. You can change it as that. But we have to take that 8 to the power of 2 up. So remember, when you take it up, you have to make it a denominator. You have to make it a numerator. You have to change the sign. That is a law. You have to change the sign. Then that will be x negative 1 over 2 is the same as 8 to the power of negative 2. 8 to the power of negative 2. So now, at the very same time here, what are we really looking for? What are we looking for? If we can check this thing, we are looking for the value of x. So I want to get rid of this. I want to get rid of this 1 over 2. I want to get rid of 1 over 2. How do I do that? That will be x negative 1 over 2 multiplied by negative 2. I have to multiply every side by negative 2. That will be 8 negative 2 times negative 2. Therefore, remember, what you do on the left hand side must be done at the right hand side. One of the reasons for doing that is to get rid of what? Is to get rid of this. So these two will cancel. Then you're going to have x. It's equal to these two here, negative and negative. That will be 8 to the power of 4. Then you are done. We have again complex questions here. So now when it comes to this one, what you need to do, remember, you must make sure that the base are the same. Then now we're going to change this 8. So that will be 2x plus 4. It's equal to, how do we change 8? That will be 2 to the power of 3. Then we have, now that the bases are the same, the law says that if the bases are the same, remember, we take the exponent. So it's going to be x plus 4. It's equal to 3. So now, remember the laws. We are looking for x, not x plus 4. So we're going to take this 4 to the other side. Remember, when you take something to the other side, that thing has to change the sign. So that will be x. It's equal to 3 minus 4. Then the value of x, it's negative 1. Then you can celebrate. Then we have the second one here, which is 81. How do we change 81? You have to change 81 in terms of base 3. So remember, if you want to change 81 when you use a calculator, that is 9 squared or 3 to the power of 4. You can just learn how to change. I think you're going to say 81 equal to shift fact in your calculator. Then now we're going to write it as 3. X minus 1 is equal to 3 to the power of 4. Then because the bases are the same, then the answer is the exponent. It's equal to 4. Then from here, we are not looking for x minus 1, we're looking for x. Then we're going to take that negative 1 to the other side. Remember, when you take something to the other side, that thing has to change the sign. Then x is equal to 5. Then you celebrate. That is the second one. Very easy to do. Then number C, we have 9. 3x minus 3 is equal to 27. Now, the question that you need to ask yourself is that, how can I change 27? Can I change 27 in terms of 3? In terms of 9? No, you cannot do that. But you can change 27 in terms of 3. Then can you change 9 in terms of 3? Yes. Then this is 3 squared. Then 3x minus 3. It's equal to, when we change 27, that will be 3 to the power of 3. Okay. Therefore now, before you drop the bases, you can remove the bracket. We've got 2 terms outside the bracket. So that 2 must greet each and everything outside the bracket. That is the law. So that will be 3, then 2 times 3x minus 2 times 3, it's equal to 3. Remember, that is the law. You have to make sure that when you remove the bracket, you remove the bracket with everything. Then now we have 3, then 3 times 2, it's 6x minus 6, it's equal to 3 to the power of 3. We are happy because the bases are the same. Then the answer is the exponent. Then it's going to be 6x minus 6, it's equal to 3. Remember, we are not looking for what? We are not by any means looking for 6x minus 6. We're looking for x. Then we're going to take 6 to the other side. That will be 6x, it's equal to 3 plus 6. Then 6x, which is equal to 9. Then what to do now that we want to get rid of 6? We have to divide both sides by 6. We divide both sides by 6. So the law says that what you do on the left-hand side must be done at the right-hand side. Therefore, the answer is 9 over 6. So now what we can do here is to say, do we have a number that can go in both 9 and 6? Basically, we have it. That is 3. How many times does 3 go into 9? It goes 3 times. And how many times does it go to 6? It goes 2 times. Then you are done. Then you can celebrate wherever you are. Then now, how do I deal with different questions, or a question that has the decimal? So that is 3, that is 10. 3x minus 2, it's equal to 0,0001. So what you can do here, because I've got the base 10 here, you can change that one in terms of 10. But how do we do that? You're going to punch in your calculator as it is. When you punch these decimals as they are, you're going to have something like 1 over how many zeros do we have? We've got 4 zeros, so we're going to 1, 2, 3, 4. But make sure that you use a calculator to change that. You're just going to say 0,0001 equal to, then you'll get something like 1 over 10,000. Then now we're going to change that 10,000 in terms of 10. So that will be 3x minus 2, it's equal to 1 over 10 to the power of 4. 10 to the power of 4 is the same as that 1,000. Then what we're going to do is to take 10 up so that we can have the same base. So remember, when you take something to the other side, that thing has to change the sign. If it doesn't change the sign, then there is something wrong with your math. Then the bases are the same. If the bases are the same, we celebrate, we are happy. Then that will be 3x minus 2, it's equal to -4. It's equal to -4. Then from here, remember, we are not looking for 3x minus 2, we're looking for x. That will be, we're going to take 2 to the other side. That thing has to change the sign. It's a must. It has to change the sign. So that will be -4 plus 2. Then we have 3x. It's equal to -2. Then remember, we are looking for x, not 3x. Then what you do on the left-hand side must be done at the right-hand side. Then we've got x is equal to -2 over 3. Then we are going somewhere. Remember, if you have any question, then you can simply tell me there. You can just send me a question, then I can explain it. Then we have something like, I think that is number E. We have 3.2x, it's equal to 192. So now one of the mistakes that students are going to do is to multiply the 2, and have something like 6x. You don't do that in math. Remember, you can only do that if the bases are the same. But because the bases are not the same, then you cannot do that. Okay, but if you had x, if you had x here, you could just multiply the 2. You could take the common factor of x on top. You're going to have 2 times 3 and then to the power of x. But then now, unfortunately, we don't have that. So what we are going to do here, it's very simple. We have to divide everything. We have to divide everything. We have to divide everything. So that will be, we're dividing everything by 3. We're dividing everything by 3. Then we have 2 to the power of x. Then you can use a calculator then. Quickly, you can use a calculator. When you divide it by 3, you are going to get 64. You're going to get 64. Remember, there are many ways to change 64. We can change it in terms of a to the power of 2, 4 to the power of 3, and then we have 2 to the power of 6. But when you come here, you don't come here and choose and say, I prefer maybe to use 2, I love to use 2, or you love to use 8. No, you check the other base. What is the base that I've been given? Then the base that I've been given is 2. So I will have to change that 64 in terms of 2. That will be 2 to the power of 6. Therefore, now I've got x, it's equal to 6. Why? Because the bases are the same. Remember, the law says that when the bases are the same, we take the exponent. We have another question here, which is 25 and to the power of 1 minus 3x. So what we're going to do here, remember, this is an exponential equation. So what we'll be doing is to take 5 to the other side. So that will be 25, then 1 minus 3x, it's equal to 5 to the power of 4. Then from then we're going to change 25 in terms of 5. How do we change it in terms of 5? That will be 5 squared. Then you have 1 minus 3x, then it's the same as 5 to the power of 4. Then at this stage, what we're going to do is to remove the bracket. Remember to remove the bracket. To remove the bracket, it's very, very important. Then that will be 5. Then 2 minus 2 times 3, that will be negative x. That will be equal to 5 to the power of 4. Then at this stage, what we're going to do here is to say the bases are the same. That is the most important thing. Then we're going to say 2 minus 6x, it's equal to 4. It's equal to 4. Then what we're going to do is to take 2 to the other side, or rather to take negative 6 to the other side and 4 to the other side. So that will be 2 minus 4, it's equal to 6x. Then we use a calculator. Remember to always use a calculator. That will be negative 2, it's equal to 6x. And then you divide both sides by 6. You divide both sides by 6. Then we're going to have negative 1 over 3, it's equal to x. Then you can celebrate. So remember, that is to say, how many times does 2 go into 2? It goes 1 time. How many times does it go to 6? It goes 3 times. So now we have this question here, 4 times 8, x minus 1 is equal to 2 over 1 over 16. So now when you see this question again, one of the common mistakes that students will be doing here is to multiply the 2. Don't multiply the 2 because they don't have the same base. So rather, you have to change everything in terms of the same base. And the bases that we have normally, that will be 2. So now that will be 2. So what we're going to do here is very simple. We're going to change 4. How do we change 4? That will be 2 to the power of 2. How do we change 8? That will be 2 to the power of 3. Then x minus 1. It's equal to 2 over. How do we change 16? That will be 2 to the power of 4. But remember, we have x outside. Then what we're going to do here is to write it as 2 multiplied by 2. Then we're going to remove the bracket as usual. We're going to remove the bracket. We're going to remove the bracket. When we remove the bracket, that will be 3x. That will be 3x minus 3. It's equal to 2 over 2 for x. Then from here, we're going to use the laws of exponent. The laws of exponent says that when we multiply the same base, we add the exponent. When we multiply the same base, we add the exponent. So that will be 2, then 2 plus 3x minus 3. It's equal to here. Remember, there's an invisible 1. There's an invisible 1. We're going to use the laws of exponent. When we divide the same base, we know what to do. We subtract the exponent. So that will be 2, 1 minus 4x as it is. So now here we are happy because what we were looking for. We have arrived to that stage. The base are the same. When the base are the same, we take the exponent as usual. So that will be 2 plus 3x minus 3 is equal to 1 minus 4x. Then at this stage, we know what to do. We're going to group the like terms together. That is very, very important. We group the like terms together. Then I'm going to say 3x. I'm going to take that 4, negative 4 to the other side. Remember, when you take something to the other side, that thing has to change the sign. So that will be plus 4x. Then you can check here. I have negative 2 and negative 3. So that is basically negative 1. So I will have to take negative 1 to the other side. I will have to take negative 1 to the other side. So that thing has to change the sign. If it doesn't change the sign, then it will be incorrect. Then I will have to add the like terms. I will have to add the like terms. So when you are adding the like terms here, remember you do not add the exponent. You only add the coefficient. So that will be 7x. It's equal to 2. Then we divide by 7. What you do on the left-hand side must be done at the right-hand side as always. Then the final answer will be 2 over 7. I hope this is very clear and easy to understand.